Hi all, welcome to my presentation. This is Zabihullah Shahrani. I'm doing second semester Master of Computer Application at University of Mysore, India. The project I have chosen for my artificial intelligence subject is lane line detection for self-driving cars. Now, the topics to be discussed are image as tensors, grayscale conversion, Gaussian blur, edge detection, masked image, Hough transform, overlay Hough image over the original image. And now in our first slide we see images as tensors. So what is tensors? Tensors are matrices with additional dimensions. Now to understand this better we'll be just moving forward to the next slide because there is the matrices and the arrows down there. It should be a little confusing. So we'll be just moving forward to the next slide for better understanding. Now, the first step in converting our image into a tensor is converting it using the Python code, which you see in the first line, image equal to mpimg.imread. These are all Python methods which converts the image into a tensor. Now, in the second line, we see that it's already converted into 960 into 540 into 3. That means we have got 960 rows, 540 columns, and 3 elements per each unit. It means the picture is divided in these many parts. So now these elements contain actually brightness of values from 0 to 255 for each corresponding pixels. And you can think of a pixel as a unit containing 3 elements. We can use it like red, green, blue, which stands for RGB. And now to visualize the images as tensors, here's just an example. As you see the fruits basket at the right side of the slide, like if you visualize it in tensors, we can see it in the red channel, how it looks in the red channel, and how it looks in green channel as well. That means we can isolate the red, green, and blue channels. So that's the process of converting of images as tensors. Now the next step is grayscale. So here what we do is, like in the previous step, we converted the image into red, green, and blue channels of different channels. So now what we do is we will be taking those different images like red channel, green channel, and blue channel, and we'll be converting all those into grayscale. So I'll be just reading out the points. We convert our image to grayscale so that we can abstract away from a tensor to a matrix and deal with raw pixel values. Treat yellow or white lane lines the same. Pixel list will be equal to color channel. Average color channel values within the pixel list RGB divided by 3. So we'll move forward for the next slide. Now in previous steps what we did was we changed the photo into 3 different colors, red, green, blue, and then we converted to gray. Now here what happens is we will take the original image and we will be applying Gaussian blur. Well, the people who are photo editors or photographers, they will be aware of this word much better. So I will just reading out a few points here. What will happen? We will be applying Gaussian blur to reduce the image noise and details, because this method will be smoothing the image before applying the canny edge detection, so we do not detect faint edges. So that's the moment we will be applying this one, and the below are some of the methods and keywords in Python to do all these function of doing blur. We'll be moving forward for the next slide now. And now the next step is to find the edges of the picture. Now in previous step what we did was we got the original image and we applied Gaussian blur in it. And now here what we do is we will take the original image and we will detect the edges. What happens here is that the image that you are about to find the edges, it should be of good quality actually. it should not be of low quality, because here we see a number C, like A, B, C, you see there, it's written that pixel below low rejected. I mean, the photo which has low pixels, it's very hard to find the edges in that. So the operation will be denied, and we cannot find the edges of the picture properly. So we'll be just moving to the next slide now. And here, in the next step, what we do is, whenever the edges are found in the picture, in the image, I mean, what we do is we will be applying a mask over the edges. So this will help to to make the lines much more straighter, so there won't be any sort of disturbance along with the lines which is created with the with the edge detecting step. So we will mask the image with the with the help of masking, actually, or we can say we can apply a trapezoidal mask over the edges. Those people who are photo editors, they will be knowing this concept much better. So we'll be just moving next. And now comes the next step, the second last step, which is called Hough Transform. Now, what is Hough Transform? I'll be just reading out one by one for you all. The goal is to identify straight lines. That's like very important for line detection. Now, how is the process done? Like for each pixel at x and y axis, the Hough Transform algorithm determines if there is enough evidence of a straight line at that pixel or not. So that's a very important part. And next are the methods and keywords which are used in Python for doing this function, which is lines equal to cv2.hookLines p bracket open canny edges. So these are the methods to be, if you want to perform this function, so we have to be applying these codes in our Python project. We're just moving forward. And now the values that you see at the left side, like for theta, RHO, these values are not actually constant, and they can change according to your own requirement, according to your own picture that you have in your project. So here what happens is, after we found the edges, we applied the mask, and then we applied the Hough Transform function. The reason we applied this is because the Hough Transform function finds the clear evidence of the line. So here we can see in the bigger image that the clear evidence of the line is appeared in the image. And now comes the last step. What happens here is, in the previous step, we created our Hough Transform image. Now what we do is, we will be overlaying, as I told you in the beginning also, the people who work on Photoshop, I usually work on Photoshop because I like photography and all these things. What we do is, we will be overlaying the Hough image on original image. That gives our perfect line on the image. There will be much more clearer evidence of the line in our image, and that's when our line detection will be started working, actually. So we'll be just more looking the next slide for the what processes we have done so far. So here is our overall result. Just starting from step A, that we had original image color, and then we changed it to red, green, blue, three different colors, and then we applied Grayscale function on those red, green, blue images, and then we got the original image, we changed it to Gaussian Blur, and then we found the edges, and then we applied the mask, and then we applied the Hough function, and finally what we did was, we got the original image with the Hough function result. We applied on it, and we did overlay of Hough image on original image, and we got our final result, and that's when our lane line detection will be started working. And now that's end of my presentation. I hope you liked it. Thank you very much.